Anatomy and Physiology Tutorials, Basic Chemistry. Why study chemistry when learning about the human body? Well, guess what? You are made up of chemicals. Biochemistry is the study of the chemical aspects of life. Matter is anything that occupies space and has mass. In your body, chemicals are in the form of molecules, which are composed of smaller units known as atoms. Found in an atom are three subatomic particles. Protons carry a positive charge and are found housed in the nucleus of the atom. Neutrons, also found in the nucleus, carry no charge, so are therefore neutral. The electrons carry a negative charge and are arranged in energy levels, also known as shells, which orbit around the nucleus. The proton number, which is the atomic number, equals the number of electrons, so the atom itself is neutral because the number of positives equal the number of negatives, which cancel each other out. Atoms are neutral, but not always stable. A measure of stability is the total number of valence electrons. When an atom's valence, or its outer shell, is full, it is considered stable. If not, it is considered unstable. Take a look at this diagram of the distribution of electrons of some various chemical elements. If an atom's first energy level is its valence shell, it requires 2 electrons to be stable. If an atom's second energy level is its valence shell, it requires 8 electrons to be stable. And so on to the third energy level, which can hold more than 8 electrons, but is stable at that number. Consider hydrogen. It only has 1 electron in its valence shell, so this element is not stable. Helium, with 2 electrons in its valence shell, is stable. Taking a look at carbon, it has 2 electrons in the first energy shell and only 4 electrons in its valence shell, so carbon is an unstable atom. Looking at neon, having 2 electrons in the first shell and 8 electrons in its valence shell, is stable. The unstable atoms, such as hydrogen and carbon, will want to form chemical bonds with other unstable atoms in order to achieve stability. Therefore, it is the number of electrons in the valence shell that will determine the reaction